Okay, all right, let's continue where we left off. Okay, we see the multiple comparison. Um, if they then here you say ANOVA procedure we have used so far show whether differences among the several means are different, significant. But if the equality of means is rejected, then it did not pinpoint for which a given means of group means differ significantly. In other words, we don't know which one is largest, which one is smallest, and their rank, their order of these means. And so there are two shortcomings. When you use t-test multiple times, you will inflate your type 1 error. And on the other hand, if you only use ANOVA, then you don't know the rank. You, of course, the box plot will help. Okay, but is there any better way that we can avoid inflating the type 1 error, or and also show the rank among the variables, the different population means? And the answer is yes, because we can use the multiple comparison. All right, and here you can see that okay, the probability, because all six t-test is if we do t-test 6 times, six pairs, and then the probability of type 1 error is alpha. So the probability of not making type 1 errors is 1 minus alpha. But if all the null hypothesis involving 6 comparisons are true, then you multiply the 1 minus alpha 6 times, which is to a power of 6, and then so that's a probability that you don't make type 1 error, and then 1 minus that, you get the probability of of making at least one type 1 error. This is the probability of don't make any error at all for all six separate t-tests. But the price you have to pay is overall your probability of at least making one type 1 error is increased from 0.01 to 0.77. And that will increase more significantly if you increase alpha to 0.05. Okay, so that shows you why we need to consider it. Consider it. Okay, so there is a variety of techniques available in the literature, such as Bonferroni procedure, Tukey, and Sheffi method. Okay, so here we limit our attention to only one, which is Tukey. Okay, and of course you can dig more into these three methods, and you will see the strengths and weakness, the pros and cons for Tukey, Bonferroni, and Sheffi. Okay, so that being said, I am not going to get into too much technical details, but may look at the procedures to find 1 minus alpha times 100% confidence intervals for difference of means with a common sample size in Tukey's method. Okay, this is to construct a confidence interval for multiple comparisons. Okay, so there are k choose 2. K actually not k over 2. This should be a typo. K choose 2. Okay, for if let's say if there are k is 4, then this is 6. So compute the following quantities. Okay, so you compute these quantities. You compare all the you have you have k samples, but then in and J is all the response variables observations, the average in that I population. So TI bar of the treatments average and so forth. So and then you calculate the variance of the within that sample. Okay, and then studentized range of distribution table, find the alpha critical value. Yeah, use the table to find it. And so for each pair, each of the k choose two pair, you compare the. So for each pair, you have a two-key interval. Then you get six two-key interval. Excuse me. And then this NR. Okay, that NR denotes the insufficient evidence for rejecting H0. Create the following table for each of the K choose 2 pairwise difference and do not reject if the two-key interval contains the number 0, otherwise reject. So then you use that interval and to see if they contain 0 or not to determine if you reject it or not. Excuse me. Okay, so this is the rationale. You create many intervals, and in other words, you use confidence interval to test for the equal to the hypothesis testing. And this support my statement before that hypothesis testing and confidence interval are actually just the two sides of a same coin. You can use hypothesis testing to do. You can use confidence interval to conduct hypothesis testing, and this is exactly the case here for two keys interval. Two keys interval. Of course, for the Q here, Q, you have to use the table. And the way this table is calculated is what makes two key a useful test. It has its own rationale in calculating the Q in such a way it addressed the issues of inflating the type 1 error. Okay, so you can see if the type 1 error is to here 1 minus since you let me see, since if you do it separately, the type 1 error will be bigger than you can tolerate. So you need to, for each interval, you need to what? You need to decrease. In other words, if the overall alpha has to be 0.01, then each separate test will has an even smaller alpha. Then so that overall you will meet you can equate this to 0.01, and then deduct what kind of alpha you need for each separate t-test. And I'm not 100% sure. I'm just use this to derive how you can get Q. Okay, if you are interested, then you can refer to the reference to see how that Q is calculated. All right. Okay, then you can compare their differences. Okay. And actually, if you look at the 10.10, okay, this is the result. And so some are equal, some are not equal. And actually, for the not equal, you can conclude that which one is greater than which one. For example, U2, U4, and this is what? Both are positive. So that means U2 greater than mu4. This is a typo. This is mu2. So mu2 greater than mu4. And this is also not including 0. So mu3 greater than mu4. What about mu2 and mu3? Mu2 and mu3 include 0. So you cannot conclude that 2 is greater than 3. So 3 is greater than 4, 2 is greater than 4. And 1 is, okay. And then 4 is greater than 5 because mu4 minus mu5 is negative. So mu5 is greater than mu4. Okay, yeah. But mu2, mu3 cannot, we can't tell mu1, mu2, mu3 is greater than mu5, but we can tell that mu5 greater than mu4, mu3 greater than mu4, mu2 greater than mu4. Okay, so this is if you use a box plot, you may see confirm the conclusion made here. Okay. Yeah. In Tukey, lastly, the conclusion is that in Tukey's method, the confidence coefficient for the set of the all pairwise comparison is exactly equal to 1 minus alpha when all sample sizes are equal. For an equal sample size, the confidence coefficient is greater than 1 minus alpha. In this sense, it's conservative when the sample sizes are not equal. Yeah, when sample sizes are not equal, then the confidence level interval may have to be bigger. That means to be more conservative, to reject or do not reject, because you don't want the overall alpha to be inflated. Okay. So Tukey's procedure to unequal sample size is sometimes referred to a Tukey-Kramer method. So Tukey refers to an equal sample size. Tukey-Kramer, unequal sample size. Only Tukey-Kramer is more conservative because of unequal sample size. Okay, I think it's good to stop here. And I already make, if you go to the week 4 assignment, you will see that the midterm our project is already available for you to work on. You should refer to instruction. I think I asked you to refer to this example and this example where you have the R code here, and you can compare these tables with the tables in the text that we went over just now, and then here, this is 10.3 Tukey, yeah. I think at least 7.123, okay, 10.7.1.2.3 to go over these so that you are familiarized with using R. Actually, just two simple command. Okay, you should be able to work this out. Okay. Yeah, good. It's about an hour. I think it's good point to stop here. And let's see if you have any questions. Yeah. Mm-hmm. Any
No,
questions?
no, I'm okay. I looked at the first example that you wanted us to do. I think it was 10.5.3.
Okay.
And yeah, the thing I found a little difficult in terms of the program was figuring out how to set it up with the unequal values from the three different treatments. But other than that, I think I eventually figured it out. But it was hard to research what command in R took out those NA values versus not.
Yes. Right.
Yeah.
You probably, I suggest that you work out this example first. Understand this
Okay.
example first, although I'm
Yeah.
not going over it with you. You can go over it yourself. Then you will know how are required that you arrange your data, and then see if you could generate something the same. Then you
Yeah.
you can go back to do it the right way for your question.
Yep.
Yeah.
Okay. Good.
Okay. Okay. Good. Great. The other guy left. Okay. Great. So I will let you go and enjoy your. Is it time for?
Rest of Saturday.
Okay.
Okay. Thanks.
Okay. 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 Yeah, I believe you will miss Switzerland, and yeah, that will be a precious experience in your life, and I hope to go.
Yes,
to
it will.
And yeah, I've been there. Oh, it's like a beautiful picture. You live in a paradise.
Yeah. Yeah. Where in Switzerland have you been?
Lausanne. Lausanne.
Oh, Lucerne. Oh, beautiful.
Yeah,
Yeah. Yeah. Yeah.
Geneva.
Yeah.
Geneva. Actually, that's
Yeah.
two
Yeah.
that's two cities on the two sides of the mountain or the lake, I think. And
Yeah. Yeah. The lake.
when
Yeah.
you
Yeah.
are there, you feel inspired very much, and I think that's probably one of the
Yeah.
good reason that Einstein could figure out his relativity. Because
I agree.
Germany kicked him
Well,
out,
I agree.
but
Well,
right. So anyway,
I think you're right.
so
Okay.
I believe you are inspired spiritually or psychologically.
Well, I'm I'm looking at the snow-covered Alps right now out of
Oh
my
wow!
window.
Oh,
So,
wow! Oh my
yeah,
goodness!
I'm in the Rhine Valley, the Rhine River.
Wow! Wow! Okay, wonderful. Take more
Yes,
pictures for
beautiful.
beautiful memory in the future.
Yeah.
Okay. Okay. All right. Good.
Okay.
Okay. Have a
See you later.
good evening
Goodbye.
and good week, and see you. Have a great week
Thanks.
next week.
You
Okay.
too.